Okay, in this chapter we're going to be looking at the modulus function. So the modulus of a number a, written as modulus a, so these two vertical lines on either side of a means modulus a, is its positive numerical value. Okay, so whenever you take the modulus of a number, you're just looking at the positive numerical value of it. So for instance, the modulus of 5 would be 5, because the numerical value of 5 is, the positive numerical value of it is 5. However, if you were to take the modulus of negative 5, then that would be 5. Okay, so it's the size of, the number, or the positive numerical value of the number. Okay, so modulus of 7 is 7. Modulus of minus 7 is 7 also. It's called the modulus, or the modulus function, or sometimes it's called the absolute value. On spreadsheets and stuff, you might see a function that might be called ABS, which means absolute function. Okay, so yeah. Okay, so we're going to look at the graph of y equals modulus x. So before we do that, let's look at the graph y equals x. So the graph y equals x looks like that. Okay, remember the coordinates are 0, 0, 1, 1, 2, 2, 3, 3, and so on. Okay. If you were to do the modulus function, okay, remember the modulus is the positive numerical value of the numbers. So if you were to put in 1, well, the numeric modulus of 1 is 1. Modulus of 2 is 2. Modulus of 3 is 3, and so on. However, remember, if you take the modulus of a negative number, you get a positive. Okay, so modulus negative 1 is 1. Modulus negative 2 is 2. So for instance, modulus negative 3 is 3. So whenever you put in the negative values, the negative x values, you're going to get positive solutions. So it looks something like that. Okay, so it has the effect of reflecting anything below the x-axis above. Okay. Okay, we're now going to draw the graph y equals modulus 3x minus 2. So first of all, start off by drawing the graph y equals 3x minus 2. So the graph y equals 3x minus 2 looks something like this. Remember, it's because of positive gradient, so it's going to be going up. It crosses the y-axis at minus 2. Okay, remember, you stick 0 in. If you want to find where it crosses the y-axis, put 0 in. 3 times 0 is 0, take away 2 is minus 2, that coordinate there. If you want to find where it crosses the x-axis, okay, you put y equals 0, so you get 0 equals 3x minus 2. Bring the 2 over, so you're going to get 2 equals 3x. Divide by 3, so you're going to get x equals 2/3. Okay, so this is the coordinate here, 2/3. Okay, now we're going to consider the graph modulus. This graph, y equals modulus 3x take away 2. So sketch the same set of axes. Remember, the modulus function has the effect of making all the positive values will remain the same, but all the negative values will become positive. So for this graph, the bit that's above the axis, the x-axis, will remain the same. Okay, and actually the bit that's on it. So this part will all remain the same. So if I put here 2/3, and I keep that bit the same. Okay, but the bit that's below the x-axis will be reflected above it. Okay, so it's sort of going to bounce off the x-axis back up. Now this coordinate here is minus 2, so whenever it's reflected up, it's going to be 2. So it's going to come up like this, and it's going to cross through 2. So this is the graph y equals modulus 3x minus 2. So first step is draw the normal graph, and then just reflect anything below the x-axis above the x-axis. Okay, so we're going to draw the graph now. Y equals modulus x squared minus 3x minus 10. So first of all, start off by drawing the normal quadratic, x squared minus 3x minus 10. Remember, to draw a quadratic, or to sketch a quadratic, what you're going to want to do is find out, obviously it's a positive quadratic, so it's going to have the typical U-shaped graph, and you want to find where it crosses the y, or the x-axis. So you let y equal 0, so you're going to do 0 equals bracket, 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 x, and the times together to give you minus 10, and add together to give you minus 3. So it's going to be minus 5 plus 2. Minus 5 times 2 is minus 10, and minus 5 plus 2 is minus 3. So that means, obviously, if these two things times together to give you 0, then it's going to be x equals 5, or x equals minus 2. So it crosses at minus 2, and it crosses at 5, and it has a typical U-shaped quadratic graph. Obviously, that's quite, you can draw it a lot better on paper. Now, to do the modulus graph, okay, you're going to have the same bits above the x-axis, so these two parts will remain the same. So if I have minus 2 and I have 5, it's going to remain the same on those sides, like that. But the bits below the x-axis will be reflected above it, so it's going to reflect up like that. okay, like a U shape, okay, that U shape will be reflected up, okay. These aren't the best of sketches. Now, let's just find where this point here is, okay. So whenever you want to find what crosses the x-axis or y-axis, you put in x equals 0, so 0 squared 0, take away 0, 0 take away 10, so that's minus 10. So then when it's reflected up, then that value there will be 10, okay. So it sort of comes down, curves up and around and back up again. Okay, and just as an interesting one, I've drawn the graph for y equals modulus sine x. So the y equals sine x graph, remember, looks like this. Okay, starts at 0, 0, goes up to 90 or pi over 2, 1, pi 0, and so on, okay, and looks something like that. For the modulus one, remember, anything below the x-axis is reflected above it, so it ends up looking something like that, which I think is pretty cool. Okay, we're now going to draw the graph y equals modulus x plus 1. Now if I was drawing a graph like this, what I would first of all do is see that the modulus isn't over the whole function, okay, it's just modulus of x plus 1. So what I would do is I would draw the graph y equals modulus x and then consider the transformations of the graph and then just shift it up 1, okay. So you're going to get the graph y equals modulus x, it looks something like that, y equals modulus x, obviously that's 0, 0 at this point here, so y equals modulus x plus 1, we'll just move it up 1 square, so then that would be 1 and it would come down like that and back up like that, okay. If it was y equals modulus x take away 2, it would go down 2 squares, okay. Remember the transformations of graphs, okay, if you had y equals 2 modulus x, you draw the modulus x graph, we just times the heights by 2, so it just gets steeper. Yeah,